Hello, here's another AQA A-level Physics multi-choice question. This one's on the thermal physics topic. So if you want to answer the question yourself, pause the video now. If you got the answer B, well done. Let's have a look at this question then. A gas occupies a volume V and its particles have a root mean square speed CRMS of U. The gas is compressed at a constant temperature to a volume of 0.5 V, so half its original volume. What is the root mean square speed of the gas particles after compression? So it looks like we're going to halve the volume if the temperature is kept the same. And it says, that's the big thing here, the constant temperature. So if the volume is halved, the temperature is the same, the pressure is going to double. So nice easy question, this one actually. We just need to use the equation that tells us that 3/2 multiplied by the Boltzmann constant and temperature is equal to half times the mass of the particle multiplied by the root mean square speed squared. So what's the key takeaway here? Well, we're not changing the mass of the particles, we're not changing the Boltzmann constant because it's a constant. So what we can see is we can see that the CRMS, the root mean square speed squared, is directly proportional to temperature. So at a constant temperature, there's going to be a constant root mean square speed. So the speed isn't going to change if the temperature remains the same. The answer is B. If you found this video useful, click on the subscribe please, share and hit the like button, and thank you for watching.